This is Domonkos Tomcsanyi. He may be probably the youngest presenter at Hacktivity this weekend, but even at his young age, he boasts an impressive CV with several publications and presentations. Amongst others, he worked out a new attack theory against WPA2 AES, and he's going to give you a presentation on something I think most people will find very interesting, especially if you have wives or girlfriends. So I'll let him tell you the topic.
All right. Good morning, everyone. I would like to say excuse all of you because of the technical difficulties, but somehow the projector just couldn't recognize my PC, so we are using currently a VNC connection to that one, so it's going to be slow as you've seen it already, but I hope it's going to be okay. Before I get into more stuff, I would like to ask all of you, just as a countermeasure, to turn off your 3G phones, or at least turn off 3G on your phones. I've taken every countermeasure. There shouldn't be any surprises, but it's always a good thing to just turn off 3G. Nothing else, you can have GSM working, but 3G, just turn it off for this presentation. Thank you. So, it's called Give Me a Phone That Cannot Be Traced, and we will see at the end of this presentation if I'm right or wrong. But before I get into stuff, I would like to talk just a little bit about me. So as I've already been introduced a little bit, I started wireless hacking and radio stuff back in 2006, and I'm currently part of a new startup company in Hungary called Bodri, and we are looking to do some fun stuff in Hungary, but currently we are just developing, so you will not hear from us for a long time, but sometimes maybe we just get into the market and you will see us. I am the guy who is everywhere talking about random stuff, and he is young. Well, that's I got this quote quite a bit of time. Well, that's what I used to be when I was 17. Now I'm 20, so I'm just old and boring, so you shouldn't listen to me at all. And I'm overusing smileys, and I got one shiny certificate to show. It's a CEH certificate. Isn't that cool? All right, so the topic, it's gonna be about phones and 3G and locating people. So as you've seen this comic, I told you they were tracking us with our cell phones. So can they track us with our cell phones? Definitely yes, but can you hide from authorities trying to find you? We shall see. Okay, just a quick thing. It's presentation versus discussion. Currently, I would like it to be a discussion. I would like it to be open to you. So anytime you want to say something, you say, oh, that's not right, you got it wrong, just raise your hand or just shout it in, because I would really like you to be involved in this, because this is a theory, so dragons are ahead for sure, but the main thing is there might be something I just forgot about or I don't know, because I'm not really working that much into the telecom industry. So anyone knows a lot about that or thinks that I'm wrong, just shout in, and then I would like to talk about it. So the agenda for today, the basics of finding a cell phone without a GPS. So we're not talking about smartphones, we're not talking about a phone that has GPS in it. I'm talking about a regular phone, just like, for example, this one I'm going to use. It's a Nokia E51. Doesn't have anything special in it. It has 3G. It's an older business phone, but it doesn't have GPS in it. So mainly, if you would like to find a cell phone like that, how would you do that? Then the second one is going to be about femtocells. What is a femtocell? How can you use it for hacking? And the history of femtocell hacking. Actually, you can see one here, right there. And just about how they kind of connect together with my idea of having an untraceable phone. Then it's going to be a live demo about which I'm not 100% sure, because it requires a good internet connection, and currently we are running on 3G, but hopefully it's going to work out. We shall see. And of course there is going to be a recommended countermeasures for operators using femtocells for sure. So finding your phone. It's a very basic and well-known technique. It's called multilateration, or many of you might know it as triangulation. And it requires pretty much 3 towers and the cell phone. And it's just pretty much the old physics formula everybody knows. Distance equals time times velocity. So if a phone can measure the time that was required for the signal from the tower to get to the phone, it can figure out its distance from the tower. So if you have enough towers, like let's say 3 towers, you can figure out how far you are from each of these towers, and then you can start like drawing circles. and more circles, and in the end, in the intersection, you will kind of know where the phone is. Also, operators can ask the phone in which cell are you currently located, which towers can you see, and so on. So an operator can pretty easily do this and find the phone. So that's pretty much the technique they use for finding a phone. For example, when the authority asks you, for example, the police is trying to find someone. Now let's get into the topic of femtocells and 3G. So 3G is the new standards, or I shouldn't say new because we have 4G already, but let's say 3G is the newer standard for mobile communication, and it is supposed to be the successor of GSM. So the exactly same services GSM offers you, which is slow data connection, voice calls, and SMS. The same stuff is in 3G, so you can use 3G for all of this stuff. And in the 3G standard, they introduced a new thing, or a kind of special thing, which is called the home node B, or as many of you might know, it's called a femtocell. What is a femtocell? As you can see here, here is a reference model of how a femtocell should work, and here is the actual femtocell. It's HNB, so home node B. So what it does, it connects via the internet to the operator's network, hopefully on a secured connection, we will see that. And after it's connected to the operator's network, it will do some authentication with the operator, and then after that, it will start acting like a mini little 3G cell. So you can think about this femtocell stuff like having a Wi-Fi access point, but instead of Wi-Fi, 3G is coming out of it. So, and then phones can connect to it, and you can configure it which phone can connect to it, any phone can connect to it, or maybe you want only your numbers to be connected to it. And it is supposed to help customers that have broadband internet connection at home, but for example, they're living in a basement, or they live in some special areas where there is no coverage at all, or no 3G coverage, and for some reason they want to have 3G at their homes, and therefore they just plug this little device in. This is actually a Vodafone femtocell. Hopefully they will not get me, whatever. So this femtocell is from Vodafone. It's an older model, but still many people use it. And there is also a newer model, but what I'm going to show you today, it works on every single Vodafone femtocell, even the ones that are in production in Hungary. So you can buy a femtocell here in Hungary too, and the same things will work with it. So let's just look at how operators usually implement a femtocell infrastructure, I should say. So here is just a little bit bigger picture of how femtocell infrastructure looks like. So that part is the home node B. That's exactly the same Vodafone share signal femtocell. It uses IPsec to have a secure connection back to the home basis, or back to Vodafone. And it doesn't have, it is running on a special system-on-chip architecture. It has an ARM processor in it, and it doesn't have any inputs or anything that could help any attacker to compromise the device, at least the current ones. So there is no SSH server, there is no HTTP server installed on it, there is nothing. There is an IP tables rule that drops everything except stuff that's coming from Vodafone and except stuff going out to Vodafone, and and it allows only DHCP packets and IPsec packets through the thing. So if you don't find an implementation error or a buffer overflow in the IPsec part of it, it's actually using an open source IPsec daemon, then you won't be able to compromise it. So that's pretty much what I wanted to say about it. But what would happen if someone would be able to compromise a femtocell? Well, you can do pretty much anything, because once you have access to the femtocell, you can create a small kernel driver that will redirect every single packet before the IPsec encryption happens. It will redirect every single packet to your program, and then your program can pass it to the IPsec part. So you can eavesdrop any calls that is going through the cell. You can perform queries against the core network, like a regular phone would perform a query saying, hey, I'm phone number or whatever, and the core network would say, okay, then you are allowed to do this and this, because based on your subscription, how much money you have on your SIM card and stuff like that, it would allow you to do certain stuff. But if you have a rooted femtocell, you can say, okay, I'm phone number something totally different, and I would like to, let's say, place a call, and you can do that freely, because why wouldn't you be able? It seems to be that the phone is connected to the femtocell. It is allowed to do that, and it's just placing a call. And also you can attack the core network if you want, so you can dump data out of it. And many people say, who work with femtocells, that the interface that is connected to the femtocell, so there's a special gateway for femtocell connections, that is not so secure. So some people were able to actually compromise the core network using the connection of a femtocell. But I already said somebody did some research on it, so yeah, somebody already did it. Okay, not the Simpsons, but there were actually 3 basic or main researchers or researches that were dealing with femtocells. And the first one is by the Hacker's Choice. They worked actually with these Vodafone boxes. And the first version of these Vodafone boxes, which I will show you right now, looks like this. Looks kind of similar to the other one, but it had serial connection in the back. And you can see a USB to serial adapter is actually connected to this one. So you would be able to see all the boot messages, and you were able to talk to the device. And they got the password pretty easy figured out. It was, for the root account, it was newsys. So wow, that wasn't long, and they figured it out pretty easily. So they actually rooted a device like this, and Vodafone was really scared. I mean, as you have seen the consequences of rooting a device, it's really bad for them. So what did they do? Well, they reacted pretty fast. What they did is they issued a software update that would turn off the serial port, kind of just telling for the embedded Linux to not listen on the serial port. And they also banned all these devices from their core network. So the Vodafone femtocell gateway now recognizes if a device is one of the hack devices, and it's just not allowing it to connect back to the network. And they also changed, later they changed the design of the PCB that's in it, and it's called the 1.5 board. This is the 1.0 board, and there's a 1.5 and the 2.0 board. And the 1.5 board does not have serial connection at all. And the new ones you can buy right now in Vodafone stores. It's a Vodafone Sure Signal 2, or that's PCB model 2.0. And that's a smaller device. It's a little bit different. And actually it uses a newer system-on-chip design, which has special fuses in it to disable all debugging and all JTagging and any kind of hardware hacking you would think into. And of course, after the production is going well, Vodafone decided to actually burn these fuses. So right now, as far as I know, there is no way to get into a Vodafone Sure Signal 2 device. Okay, the next research was by these 3 gentlemen who are working at the Technical University of Berlin, so they are working all in Germany, and they presented at Black Hat 2011, and they used a different femtocell, which is currently in use in France by the operator called SFR. And the funny thing about that femtocell is that that femtocell is a lot worse in terms of security than the Vodafone one. Why? Because, for example, it has an HTTP server running on it. And of course, the server was running with root privileges, and the researchers just found out a little buffer overflow in the server code, and they were able to compromise the device pretty easily. And also they performed some hardware hacking, and of course there was a JTAG and serial connector which allowed them to hack the device fully. They have a nice blog post about that, going through how they found the vulnerability in the HTTP server, how they figured out what payload to use and stuff like that, and it seems like a normal exploit, so it wasn't very special. And they presented all of the things I talked about earlier, like what could cause a problem. They presented all of these problems one by one, each by each, at the Black Hat 2011. And actually this femtocell is from one of these guys, from Kevin. He was really nice and helpful, and when I asked him via email, he sent me this one, because right now you cannot buy 1.0 boards anymore because they were just, many of them were replaced by Vodafone, so they just went to the customer and said, your share signal is cool, but we would like to change it to this one. It looks exactly the same, nothing special, you don't need to worry about anything. But therefore they have all the 1.0 boards at their base, so they are not giving it anyway. So I was really happy that Kevin offered me this one, so I can just show a little bit how it was back in 2009 when the Hackers Show was doing the research on it and what they were able to see and do on the femtocell. And the last one is a pretty new one. It's by the group called Fail Overflow, and it's a funny one actually. It's for the AT&T femtocell, which is currently in production, and you can buy it in the US. And that femtocell is a lot more complex than the Vodafone one. I will tell you later why. But the funny thing was that it was a little configuration error that caused all the trouble. And the configuration error was so easy because what they did is they had a backdoor installed on the AT&T femtocell, and it was configured to listen on a specific port, and whatever command would just come in on that port, the femtocell would actually execute that command with root privileges. But the funny thing was, there is more. The funny thing is that they made it, the configuration was so that they made it to listen on not only on the IPsec connection that goes to the operator, it was listening on 0.0.0.0, which means from every single network, even from your home network, you were able to access it and it will listen to you. So what the guy just did, he figured out there is a root shell for me right now, so he uploaded just a little program to turn on SSH, and from there, he was in the device. That's AT&T. Okay, so as I already said, I'm working with Vodafone femtocells. So, and I already said they are pretty secure. They have these fuses, they have a new PCB, they have configured the software right. So let's assume that the femtocells nowadays in use are pretty secure for the Vodafone part, let's say that. So what can we do? There is still one thing we can do without rooting the device. So we could just handle the whole device as a black box, and I will show you what we can do with it. So how to become untraceable? Well, the femtocell is using the internet to communicate with the core network, as I already said, via IPsec. And what the operator needs to verify that the femtocell is operating in such a place, I mean physically in such a place, where it's allowed to do it. For example, for the Vodafone UK femtocells, it's only allowed to work inside of the United Kingdom, for sure, because Vodafone UK does not have the right to emit radio signals anywhere else in the world, right? But how to verify that the femtocell is actually in the United Kingdom? Well, Vodafone is using the IP address. So if the femtocell is connecting back, Vodafone will naturally see the IP address it's connecting from to verify the location, and it also requires you to register the femtocell with them and tell them where would you like to use it. I'm just highlighting the stuff I'm kind of I find funny because, so the location is based on the IP address and the address I'm giving to Vodafone. I mean, which one of these cannot I forge? I can forge both of them, right? Okay, how to do this? Let's get to real stuff. So how would you be able to have a Vodafone femtocell connected back to the core network from anywhere on the world? Well, go to eBay, search for Vodafone Sure Signal. You will find plenty of these. You can buy them for like 50 or 60 bucks. It's not so expensive. You buy it and the guy will just mail it to you easily. Okay, but the next one is a pretty tricky one. You need to have a Vodafone United Kingdom SIM card to register the femtocell with the SIM card account. How would you get a Vodafone UK's SIM card? Well, you go to eBay, you type in Vodafone prepaid SIM card, and you will get plenty of those. Even you can get one with like 10 or 20 British pounds, so money is loaded on it. It's a prepaid SIM card, and it works pretty easily. So you just wait a little bit, and the mail will give you everything you need. Okay, now you have a SIM card, now you have a femtocell. Good, let's start. If you go to vodafone.co.uk, you need to register your SIM card, and after that you need to register your Sure Signal. All right, so they're asking for a Sure Signal postcode. So they would like to know where I'm using the device. Well, they need a postcode. How should I get a postcode from the United Kingdom? Come on, I mean, I cannot do this. I'm living in Hungary. Yeah, Google Maps is pretty easy for that. You know, you just go to Google Maps, choose a random location in the UK, right-click, say what is here, and it will tell you the postcode, it will tell you the address. And it works. I tried it, and it's working. So yeah, I am a registered owner of a femtocell, and I'm currently located at the Leather Market Street in London, if anyone would like to know that. Yep, I'm right there. You can see me. I'm smiling on the camera right here. Okay, now we just need a United Kingdom IP address to connect back to the core network, right? There are tons of free and even paid VPN services, but Vodafone UK was a tricky one here because they blocked almost all of them. So these people are really smart. You shouldn't mess with them, right? You can see it. They need an address, they need a postcode, and now they banned all of the UK IP addresses you would be able to connect here. Well, yeah, I had to rent my own VPS server, and I set up my own VPN. It cost me like 10 USDs. So right now I have a virtual private server running in the United Kingdom, and the IP address of the virtual private server looks just like an ordinary UK IP address. Nobody knows I'm running a VPN server on it. So here I go, right? So now about how to get like really untraceable. So let's say now you can see that from anywhere in the world I will be able to communicate with the rest of the world as a Vodafone UK customer, and let's say somebody would like to find me. Okay, so they would go like, okay, where is this guy connecting from? Well, the only cell tower it can see is the Sure signal. Okay, so where is the Sure signal femtocell located? Okay, let's figure it out. Here is the IP address. Okay, that leads nowhere because that's only a virtual private server. All right, then let's go back and figure out where is the address. Okay, we go to the address, Leather Market Street, there is no one using that femtocell. Well, that's tricky. Okay, let's figure out something else. How about we go to the VPS server and try to get all the logs from them and figure out who was connected in that specific time frame to that VPS server. And well, what would I say? It's my VPS. I can do whatever I want. For example, I'm not having any logs. I'm shredding it every single second. I'm not taking any logs. So how would anyone figure out who was connected to that server? But even if there's someone who figure it out, I can do stuff like, okay, chain loading all the VPNs, right? Because I can connect to my VPN from anywhere on the world, so I can just use like proxy servers or whatever, jump around the world, and in the end just connect back to my VPN server, and there I am. So how would you be able to figure out where I am? I don't think there is any way to figure out where I am and where I'm placing that call from. So I have a cell phone that is able to place calls, receive calls, text messages, whatever, and nobody would be able to figure out where I am physically located. So here is the solution again, just a bigger picture. So I have this Sure signal here in Hungary, and it's connected to the internet, and via the internet it's actually going through my VPS server that is located in the UK, and that VPS server goes to Vodafone actually. And Vodafone cannot figure out if I'm in the UK or not, and it's just as simple as that. If I would be able to use like 4G LTE, or now I'm going to use 3G, I can even be in a car and moving around with my femtocell and having just a little 30-meter radius Vodafone UK cell around me, and I can go anywhere I want. When I have 4G coverage, for example, in Hungary or whatever country I'm living in, I can be whatever in that country. So I can even move more, and nobody would be able to trace me down, as far as I think. Okay, let's get to the demo. So here you will be able to see my phone, my Nokia E51, and as you can see, I'm unlocking it. And as you can see, it is connected to the Hungarian Vodafone network currently via 3G. And so if I would like to place a call, then we just turn up right now because the audio will go through Bluetooth back to the system you can hear. So that's the Vodafone customer service number. If I try to call it, it will just fail. Of course, it cannot be connected. All right. And it cannot be connected. So let's try something else. Let's open up my virtual machine that is right here. So, all right, Wow, okay, the screen is just a little bit big. Okay, here we go. It's getting back. Okay. Unlocking. So here I have Wireshark open because we will be able to study the packets a little bit later. But the part is like, I set up everything. So here is my, I think that's my server. So you can see it is running. It is in the UK. I will not shut down. Wait, I can show you actually. It's in the UK. IF config. All right, it's just a little bit slow, I guess. Okay. Okay, I cannot type in it. Okay, you will need to trust me on this one, I guess, because I don't want to mess up the stuff I set up before the thing. So it's located in the UK. So what I'm going to do now is, you can see the short signal is connected to my Ethernet port, which is connected to virtual machine, and all it does is just a little bit of IP tables magic that will get all the packets coming from the short signal directly to the VPN and directly to the United Kingdom. So hopefully we will see it working. Oh, I need to check one thing because we changed the internet connection, so that might cause a problem. It seems to me that it's still connected to the server. Seems to be good, but okay, the client seems to be not good. Let's connect again. Or okay, it says no route to the host, but I think it might be connected. All right, here we go. Why is there no route? All right, let's stop this again and try this one more time. Okay, just a sec, I guess. Or it might be. Okay, wait, it might be working. Okay, let's stop the server and then we will see. Oh, my SSH connection with the server just broke down. Okay, that makes some sense. All right, let's close this down and let's open up a new terminal here. Okay, here we go. Just one little script to log into SSH and starting. All right, I will not hit that again. Come on. I don't know how. I call it server.conf, I'm pretty sure. Oh, okay. Let's kill all VPN and figure it out. Oh wait, what the heck? Okay, so I could not connect to my server. That seems to be shitty. Well, that's not looking good at all. Maybe my Wi-Fi is bad. Oh, it seems to be I'm having internet access. Okay, let's try to boot up the. Might be the problem with the virtual machine, but maybe now. Okay, no route to the host. Do I have internet in here? Okay, it has DNS, but no internet. Okay, that is one heck of a problem. Okay, that's Ethernet 0. Okay, let's bring up the virtual stuff. Just a sec, I think I will be able to figure this out pretty soon, but let's say if I'm not getting anywhere in 5 minutes, then I'm gonna change for sure. Okay, connecting back. VMnet 0 should be up and running now. Let's run a DH client on Ethernet 0. Okay, don't mess with me, Linux. Here should we go. Okay, wait. Here we go, I got internet. Yay. Now I can connect to the SSH. I hope it should. Oh, here we go. Okay, that's cool. That's now really cool. Okay, I just need to kill all OpenVPN. OpenVPN, here we go. And then do OpenVPN -- config and the server conf. Okay, server is running. And I will just run this routing script, which is of course not working because the SSH on this one is still dead. But I will be able to fix that in a sec. And let's do the routing script. I hope you have 3G. Actually, this phone should have 3G enabled because otherwise it will be really slow. And Vodafone is actually checking you. What they do is if they have a latency more than 150 milliseconds, then it will not allow for the femtocell to start broadcasting because then the phone calls would be just choppy and stuff like that you would not like to get into. Okay, and now I can connect. Okay, I'm connected to the VPN server, good. Now I'm ready to roll. Okay, so what I'm gonna do is get back to Wireshark and then start listening on ETH1 because that's my Ethernet card. So you will be able to see only the packets that are coming from the femtocell. So I plug it in. And here we should go. Slowly, and here we go. So it's starting up a DHCP, trying to figure out where it is, trying to get an IP address. And once it gets the IP address, it will try to look up one of the Vodafone servers. And then once it's find an IP address, it will try to do IPsec with it. While it's doing this, I would like to show you the hacked femtocell, just how the boot process looks like on a hacked femtocell. So here I have PuTTY connected to my serial port, and I will plug in this femtocell too. So you will see how it looks like. So it's using U-boot to start up the stuff. It's just doing some self-testing in the beginning, testing the RAMs, and after it's up with that, it will start up the embedded Linux. Well, it's not really seeable. Can you see it? What would you say? It's not so good, right? Maybe I will change the color to yellow, and then maybe that will be better for you. We will say appearance, and hopefully I have it here. No, that's only the script. The colors, here we go. Default cursor text, if I'm right.
Should be the foreground.
The foreground? Okay, thank you, man. I will get it to yellowish. Apply. Okay, maybe a little bit better. Okay. Okay, what just happened here? Because it's saying something like erasing the whole device, and I don't really like that when it's doing stuff like that. Maybe there was a problem. I have a lot of problems I can see. Okay, maybe there was just a bad block at the NAND. This OK should be good. Yeah, oh, I see. So it was scanning on the file system and it just found some errors, so it should be booting now. So let's just go back a little bit and see what just happened. Okay, so here we had it started booting the image. It's an ARM embedded Linux standalone program. You can see it here. It's uncompressing it, so it's just uncompressing the kernel. And then it started checking out all the ingredients on it. So you can see it has a CPLD on it. There is also a little FPGA on it for signal processing. And then here you can see it's the PC202 board. So it has the Pico chip 202 system on chip on it. That's an older chip from Pico chip, and Pico chip is the biggest, I should say, brand or company that is creating 3G femtocells, actually just system on chip solutions for 3G femtocells. So it's not doing a factory reset and so on. And here we go. So right now it's just loading in some drivers. And as you can see, it's a pretty funny message up here. I will read it loud if I can. This system is restricted solely to the operator's authorized users for legitimate business purposes only. The actual or attempted unauthorized access, user modification, blah, 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 blah. You should go to hell and die. That's what they say. But if you hit enter, it will give you a login. So I can say root. And I already told you it's the password new sys. So here I am. Root login to the femtocell. So that's how it looked like to the guys at the Hackers Choice back in 2009 when they did the research. And this, here you can see, oh hell, I'm sorry, but of course we have problems again. Let's see how the lights are showing. Yeah, because it could be good, because when it's blinking, okay, it's not showing it has internet connectivity. And I know why, because I screwed it up again. I have one little more script, which I did not run, of course. Here, it's called other stuff. And it should be connected now. Maybe. It's doing some ARP magic. It's doing a DNS query to a Vodafone. Oh, here you go. So you can see it is now doing the authentication part of IPsec. And in a second, if it goes well, then it will start broadcasting. And the internet connection seems to be good, but I need one more thing, that little check mark to be lighted up. But you can see ESP packets here, so it's actually communicating. Here you have a lot of ESP packets. That is showing that it's communicating with the core network of Vodafone. And this light is blinking slowly, so it should be ready. I'm pretty sure now it's testing the network connection. So hopefully the 3G phone we're using will be okay in terms of speed and latency. And let's see if it's working or not. Okay, it seems to be okay. So let's try with the phone to connect to this new network. Unlocking the phone. And you cannot see it. Wait, okay. It's still connected to the Hungarian one. So let's go to the settings and try to change the network. Let's go to, okay, this is not the one, this one I want. Phone, and then go into network and change the operator mode to from automatic to doing it by hand. Just make it a little bit smaller so you can see the whole screen up there. So it's searching for networks, and hopefully, yeah, this looks good. Vodafone UK is up there. All right, let's connect to it, right? Okay, I just need a little bit more time when it's connecting. And it's already told me that the home network is selected. And here you can see I'm connected to Vodafone UK. So the next thing will be my Bluetooth connection just broke with the phone, but I will just get that back in a sec, because I will have a Bluetooth audio connection, hopefully. If it's not working, I'm just gonna call Vodafone from here and then tell them it's not working. Actually, I can. All right, so my Bluetooth just broke, or did it? No, it is showing actually. Okay, let's try. Hope we will hear something. Okay. Okay, Bluetooth is not going through for sure, I can see that.
Find out your current remaining call credits by dialing **1345#. We've got 3 options for you to choose from.
Here we go. Connected to Vodafone United Kingdom. I have the customer service online. I can call them for free because they are free from the United Kingdom, from their own network. And I did it on 3G, thanks to you. Thanks again for the phone. I got it from my nice friend here in the front. Okay, so that was my demo, and Of course, I'm pretty sure some of you would like to do it too. So here are the problems with reproducing my demo here. It is totally against the terms and conditions of the Vodafone United Kingdom because it specifically says the femtocell should only be operated in the United Kingdom. It is totally against all the laws because you are pretty much jamming on a frequency. So currently I am jamming on a specific frequency which is the property of the Hungarian Vodafone, which is quite funny because it seems that both Vodafone in the UK and in Hungary using the same frequency for 3G. But I tried to contact them and we had many emails about this and tried to get an official permission from that, but they didn't give me anything, and in the end they said, okay, you can do it, but you need to ask actually the government because we have an agency that is coordinating all the frequencies. So I called the government. Fortunately, I had one of my friends were actually working in that agency, and I called him and he said, no, it's totally up to Vodafone to let you do it. So I was just kind of ping-ponging between the two authorities, and in the end I was like, heck, I will show you this demo. I don't think it will cause any problems or interference for anyone because it's just like a 30-meter radius and it's not even that thing. But if you really want to do all what I just did, everything is up on the Hackers Choice Wiki, and I had a link to that. It's actually thc.org/Vodafone. Everything from setting up a VPN server to creating IP tables rules, everything is up on there. So you can do whatever you want. It's up and free, and you can read it. Okay. And let's get to the operator standpoint. I don't want people to do this because it's hurting me, because they can go anywhere in the world and not pay any roaming fees, and actually they can just call from wherever they want and I cannot trace them. So what would make this impossible to do? Well, the good thing would be implementing something that would verify the femtocell's location. Here are some of my ideas. GPS is an option for sure. As you have seen, I didn't tell you, but or maybe I did, but in the AT&T femtocell, they are actually having GPS in it. But I think using GPS is pretty much just against the purpose of the femtocell, because tell me a location in the world where you don't have 3G coverage, but you have GPS coverage. So these femtocells are especially for basements and buildings with walls and thick walls actually that do not let any radio signals through. So how would you be able to get a GPS fix on the device? I don't think that's even possible. There might be some there might be some places where you can do this, but I don't think it's a good idea. Okay, what I would think would be a better idea is actually, these cells have a 2G chip in them too, and this 2G chip is just like the ones you're in your phones, and that 2G chip should be able to look around for neighboring towers and figure out if those towers are in the UK or not. Well, that's only an option if you don't have 3G but you have 2G. But if you don't have even 2G, then I wouldn't be able to figure out any good solution for that. So I would like to ask you if you have any better idea for the operators, because they're listening, I hope, to figure out where exactly the femtocell is located. Okay, so I pretty much figured out everything, I guess. Okay, I would be open to questions now. Questions and comments. Yes? Well, first of all, it's against all the laws and the terms and conditions. I couldn't say it. I couldn't say stuff like, yeah, go out and do it, because then Vodafone would probably sue me for that. But it's against the law. If you want to do it, taking your own risks, go ahead. I mean, why not? But actually, it is violating all the rules. So actually, you can get sued for this, and you can get into prison because of radio jamming, pretty much. It's like a pirate radio stuff. So you will get into prisons. Because actually you are using I'm now using Vodafone's frequency, and I'm not allowed to do that officially. Any other questions, comments? All right then, I will let you up to lunch. Thank you for your attention.